Hello, you guys. Today is day 12, and we are looking at lessons 52 and 53. So, lesson 52, we're using unit multipliers to convert measures. So, again, a unit multiplier is just a fraction of two measures that are equivalent to one. So, like 1 foot is equal to 12 inches. So, we can say 1 foot over 12 inches or 12 inches over 1 foot. Those are equal to each other. So, that's still equivalent to one. It's how we convert measurements. And then we can convert mixed measures, unit to single unit measurements. Okay, so two different concepts we're looking at today. So as we said, a unit multiplier, this is probably just review, but anything that's equal. 5,280 feet is equal to 1 mile. So we can use that as unit multiplier. 60 seconds equals a minute. So that's a unit multiplier. So anything where it's equivalent, because again, this is equal to this. So top and bottom, even though it's inches and feet, they're still equal to each other. So it's still 1. So we're not changing. So like 5 feet is 60 inches. They're the same distance, even though we're using two different measurements. So we'd use the unit multiplier to get those. Okay, example 1, the sapling apple tree is 64 inches tall. Convert 64 inches to feet. So we would do 64 inches. And then how do we know which way do we want to use feet in the numerator or denominator? Well, we want to get rid of inches and end up with feet. So I'm going to put feet in the numerator and inches in the denominator, because just like any number over itself cancels out to be 1, same thing with any units. So inches and inches are going to cancel out. I'm going to be left with 64 times 1, and then this would be 64 feet divided by 12, which gives me 5.3 repeating feet, or we could call that 5 1/3 foot. Okay. So 5 1/3 feet tall, or 5.3 repeating forever feet. If I did that correctly, yeah, looks like I did. Okay, so you just multiply it. Okay, which one do you put top? Which one do you put bottom? It depends on what you're trying to cancel out, which ones you're trying to end up with. So we get rid of the inches, and we end up with 64 over 12, which is 5 1/3, or 5.333 repeating forever. So in addition to canceling units, in example 1 and 2, could we also cancel numbers? We can use unit multipliers to convert measures to desired appropriate units. Appropriate units are correct and meaningful to the intended reader. So if we're talking about, the distance from Earth to the sun, we might use miles, kilometers, or even, light years to explain, how long it would take light to travel from there to here, but we probably wouldn't use inches or millimeters or something like that. It would just be such a large number, we wouldn't be able to make sense of it. So let's look at example 3. Daniel is buying refreshments for a meeting. He wonders if 4 quarts of juice is enough for 30 students. If 4 quarts, a reasonable amount of juice for the meeting. If not, suggest a more reasonable quantity. So 4 quarts divided by 30 students. Okay, that's going to give us, 4 quarts is equivalent to 32 ounces, which is 128 ounces. So after we convert quarts, which again, we don't really buy things in quarts. Usually if we're buying soda or juice or whatever, it may be gallon, half gallon, or usually it comes in ounces. So we have 128 ounces divided by 30 students. 4 quarts is probably not enough. Getting 4 ounces of, refreshments or of juice, that probably isn't enough, because even your smaller sodas are usually 12 ounces. Larger cans are 16 ounces. So 4 ounces of anything to drink probably isn't going to be enough. Samantha drove 100 miles in an hour and 45 minutes. She drove 100 miles in an hour and 45 minutes. How many hours did it take Samantha to drive 100 miles? So 45 minutes, we want to count that as hours. So that way we are dealing with not minutes and hours, we're just dealing with hours. So how many hours did it take her? Well, 1 hour and 45 minutes. Well, 45 minutes is 3/4 of an hour. So we would have 1 hour and 3/4, or 1.75 hours. Again, usually with time, just like with money, we use dollars and cents. Time, we usually use hours and minutes, and that's fine. But if for whatever reason we wanted it to just be in terms of hours, it'd be 1 3/4 hours. To measure a room for carpeting, one converts the length and width of the room from feet to inches, from feet and inches to yards. A room that is 13 feet and 6 inches long is how many yards long? Okay, well, 13 feet 6 inches, that would be 13.5 feet, is half of a foot, 0.5. So then 13.5 divided by 3 gives us 4.5 yards. So the room is 4.5 yards long. Practice set. We'll go over together. Okay. Lesson 53, solving problems using measures of central tendency. So some of those different ones that we've talked about are mean, median, and mode. We've talked about range, minimum, maximum, quartiles, things like that. But central tendency, we want to know kind of if we're describing overall the data points, sometimes the mean or the average is the best way to express it. Sometimes the median is a better, expression, and sometimes the mode is. It just depends on what information we're trying to display. So let's suppose a popular television show got these ratings over its season. We can make a line plot and graph them. We would do all 20 numbers added up and then divide by 20, and the mean would be 15.21. Median is our middle number. If we order from smallest to largest, it's going to fall in the middle. If it's an odd number, we're going to land on the median. If it's an even number of data points, we're going to have to take the average of the two middle numbers. So it's not always going to be a number that appears in our list. That's just one extra step we have to take depending on this. So like if we started with these and we counted backwards, we wouldn't land in the middle. We'd land on 15.2 and 15.3. So we would take the middle of that would be 15.25. So we take the average of those two numbers or find the number that's halfway between. Same thing, that's 15.25. And then the mode is the most occurring number. So mean, median, mode. Depends on what we're looking for. Sometimes the mean is better, sometimes the median, and sometimes the mode. And then the range, we take the largest and subtract the smallest number, and that tells us our range of values. A histogram, we've watched a video on this, we've done a few ourselves, is another way that we can show the information, okay, the frequency and the range of numbers for each bar, okay, and then how many times it appeared there. All right, so a lot of different ways that we can look at this. So the owner of a cafe was interested in the age of her customers in order to plan marketing. One day she collected these data on customers' ages, 28, 33, and all the way through. So we have people in their 30s, 40s, 20s, and a few people in their 70s. So if we make a line plot, okay, we would plot them out, okay, how many people appear on each one, and make sure your line plot can encompass all of the numbers. So 20 to 80, that's pretty appropriate. The average, okay, we would add up all of these numbers. We have 1, 2, 3, 4, 5. So we have 10 different people that we basically accounted for. So we'd add them up, divide by 10, line them up from smallest to largest. The median was 36.5, and the range was 48. There's no number that repeats itself, as you can see. There's no X's marked up to give us the mode. So the mode is not reported. We wouldn't say there was 10 modes. We would say the mode, there is no mode. Because if there's no repeating numbers, well, all appear one. So that doesn't really give us an indication of which one is more frequent than the other. B, which measure, mean, median, mode, best represents the typical age of customers? Again, this is kind of more an opinion question, but if we look at the line plot, it looks like most of the numbers occur here from 25 to early 40s. So that's where most of the numbers are occurring. And then we have probably an elderly couple that came in 73 and 75 that are way out here. So they're going to bring up the average by quite a bit, just because those are two higher numbers than the rest. Whereas the median, it just starts at the end and works our way in. So 1, 2, 2, 3, 3, 4, 4, until we get to our median in there. So I think the median would be a little better reporting for kind of the typical age of a customer in this cafe, I think would be a better indication. 42 and 36, I mean, that's not a huge disparity, but if you said your average or your typical customer is in their mid 30s, I think that would be more reasonable than saying they're early to mid 40s, because really we only have these two in their 40s and then these that are obviously well past their 40s that are bringing up that average. Let's look at this. Josiah sells 3 different hats to test their popularity. His sales are reported in a bar graph. The height of each bar corresponds to the number of hats of that type Josiah sold. So type 1, 2, 3. The number sold 10. This looks like 4, and then this one's at 7. So find the mode of the data. Well, obviously type 1 sold more than type 2 or type 3. Why are we not interested in the mean or the median? Well, there isn't really any mean. I mean, if we found the average number of hats sold, then they would all be equal. That doesn't really help us out. So we want to know which one is our best seller. So the average wouldn't really help us. The median, there's not really any way to express this numerically from smallest to largest and find a median. So the median wouldn't really help us out to find what's in the middle of this. For this example, we want to know what the mode is. If I'm running a business and I know one product I sell sells way more than everything else, I'm going to put my resources and my efforts into producing more of that product because it's going to make me more money. So the mode in this example would be probably the best expression of what's the best seller, which hat type number 1 of the hat that you want to continue to make or you want to continue to sell. So this was some terms that may be new. In this case, the data Josiah collected was qualitative data, the hat type, and not quantitative data. So we weren't given numbers. Yeah, we had numbers sold and different things like that. So mean and median are not important for this. So it's just qualitative of which type was more popular. So there wasn't really any numbers to go off of as far as a range of values to come up with a mean and median. It wouldn't really help us in this example. All right, we'll go over the practice set in class, and then we will continue on with our next lesson. When we get there, we'll be looking at lesson 54, but that is all we have for today.